Hey guys, this is Amir P, who's doing my intern under the Sparks Foundation for the role of IoT and Computer Vision, GRIP April 21 batch. And this is my second task, object detection. I have already worked out in Google Colab and I have uploaded in GitHub. Okay, so I'll show you through GitHub itself. So I've used Keras. Keras is a minimal Python library for deep learning purpose. Okay, and the first line from keras.datasets import cifar10 means that uh, it provides a few datasets that can be used for debugging a model, and cifar10 is like converts an image to a byte file. Next we have the keras utilus import np-utilus. This package provides utilities for keras such as modified callbacks, generators, etc. And np is used to convert an array to a label data. From matplotlib import pyplot as plt. Pyplot is a collection of functions in a popular visualization mat, matplotlib. Its functions manipulates elements of a figure such as creating a figure, creating a plotting area, plotting lines, etc. And import numpy as np used for working with array. And from pil import image creates instance of images by loading and processing. Okay, so the next thing is import sys provides various functions and variables that are used to manipulate different paths. Import keras, uh, print keras dot brackets format. It's for checking the version of the keras API. So I've checked it and I've found it that it is 2.4.3. So the next thing is to load the data and xtrain, ytrain, xtest, ytest. It means that xtrain is the training data set and ytrain is a set of labels to all the data in xtrain. Okay, so data exploration. So we are trying to get the training images of the shape. Okay, and we are getting the output. Next is to create a grid of 3 into 3 images, and the for loop creates a figure and grid of subplots. plt.im shows like displays the data as an image. So plt.show starts an event loop, looks for all currently active figure objects and opens one or more interactive windows that display your figure or figures. So that's how this has taken place. So the next thing is a pre-processing thing. Uh, so next thing is a pre-processing thing, and we are using the seed is equal to 6, and we are using it in NumPy, and we are pre-processing the data, and we are doing the training and labels. So we are normalizing the inputs to 0.0 to 1.0 from 0 to 255. So xtrain is equal to xtrain dot as type. It's like training data will have to be converted to 32-bit floats, and xtest not only for predictions but also for evaluation purpose. So why do I divide it by 255? Division by 255 will ensure that the input features are scaled between 0.0 and 1.0. So that's the reason. And print x underscore train 0. Neural networks are exceptionally good at fitting to data so much so that they will commonly overfit the data. Our real hope is that the neural network doesn't just memorize our data and that it instead generalizes and learns the actual problem and patterns associated with it. Let's look at this. So that's how it takes place. I have initialized to 0, so I'm getting the answers with respect to 0 at the starting. Okay, so the next thing is class labels exploration of 10 categories. So the same thing, but now we are going with, now we want labels. So y train 0 is like to see its corresponding label. So we are getting it as 6. So one hot encoding the categories. The first line is like converts the array to label data. Generally, it has a range of 0 to uh, nb underscore classes minus 1 to one hot converter to categorical. Okay, and the same thing is repeated, and it's done for test also. Okay, so the previous steps which I explained above is the same thing repeated here. So the next thing is building the all CNN model referring to the paper. Okay, so from Keras models, importing a sequential. It means like the sequential API allows you to create models layer by layer. And if you're the next line dropout activation has too many applications in it. It's like applies average pooling on the spatial dimensions until each spatial dimension is one and leaves other dimensions unchanged. Keras Conv 2D is a 2D conventional layer. This layer creates a convolutional kernel that is wind with a layer's input which helps produce a tensor of outputs. The dropout layer randomly sets in put units to zero with the frequency of rate at each during training time, which helps prevent overfitting. So Keras.optimizers import SGD. Keras provides SGD classes that implements the stochastic gradient descent optimizer with the learning rate and momentum. So this is about defining the model function. So the same thing which I explained now, dropout, conv2d, it's repeated here. Okay, and this is for defining the model function. This is for the software activation. Okay, and this is for loading the weights. So we are then defining the hyperparameters. Okay, and we are building the model. Now we are defining the optimizer and compiling the model. So these are the additional training programs. So epoch is an important thing. Okay, it is like a hyperparameter that defines the number of times that the learning algorithm will work through the entire training dataset. And batch size is also important. It is a term used in machine learning and refers to the number of training examples utilized in one iteration. And if going for a fit model, it's for fitting the data in. So this is the output. It took for me around 1 or 2 hours. I didn't use GPU, so it took around 1 or 2 hours for running this data. Okay, and this is the class range. So the class range I've taken is from 0 to 10, and I'm just naming it as airplane, bird, and randomly. And I want the class labels to be fitted in a dictionary. So I'm fitting them in a dictionary and I'm printing it. So that's how I get the keys and values over here. Okay. Now I'm generating the batches. Okay. So I'm generating the batches. So what happens is um, everything gets fitted. By setting verbose to 0, 1, or 2, you just say how do you want to see the training progress for each epoch. If your verbose is 0, will show nothing and it becomes silent. Now we are printing the predictions of it and we are getting the output. Next is for image and predictions. And NumPy sum adds up the values of a NumPy array. Okay, and that's how you get the answer. It gets added. And the next thing is class result is equal to np.argmax. Argmax is an operation that finds the argument that gives the maximum value from a target function. And that's how it gets the result. Now I want the results. So I'm just giving the normal graphical plotting how, how I want the answer. This is a normal graphical plotting. Okay. And enumerate is like takes a collection and returns it as an enumerate object. Okay. For example, you can have a tuple as an example for enumerate. Then I'm setting the iteration and I'm checking it and I'm displaying the images according to the graphical axis. And that's how I get my prediction is deer and I get it as deer. Prediction is dog and I get it as dog. And that's how it happens. Thank you.